Welcome to Csis 248 Operating Systems Programming. This will be the first in a series of videos about the basics of programming in the C language. So, C is a lot like C++. If you're familiar with C++, C++ actually contains C, and so C is simpler than C++. The big difference being that C does not have classes. C++ does. If you're used to Java and not C++, the big difference is pointers. And what are pointers? Well, you'll see the difference when you get to it. It's a big difference, and it makes C a lot harder to use if you're coming from Java. If you're coming from a C++ background, it's actually not so bad. Java is much more protected, much safer, and easier to use. But it turns out both C++ and Java come from the C programming language. So C was first, then came C++, Java, C#, and a few other languages. So C was formulated by a famous programmer named Dennis Ritchie in 1973. So at the time of this video, it's about 40 years old. It was made specially for the Unix operating system, and so it's especially appropriate that we study both Linux or Unix and C in the same course. While the early versions of Unix were written in assembly, quite a bit of it was written in assembly, the programmers quickly realized that programming using a higher level language is probably a better idea, because if you change the hardware just a tiny, if you get a slightly different hardware and you get new assembly language, or some of the assembly language instructions are gone, then you have to change the entire program. So it's not so great. It's much better to write in a high-level language and then compile it. So the fifth version of Unix was written mostly in C. There was still assembly language parts of it was still written in assembly language. So there have been many standards in the last 40 years. One of the ANSI standards is from 1999. It's the ISO 9899 standard, and that's pretty much that's the one that most people use when they say they're using C. The C in Visual C++ defaults to C90, and that is also in Microsoft. In the Microsoft world, that is pretty much the standard. So it's slightly different from. There are differences from the later version. The very latest version is C11, as in the 11 stands for 2011. So this is a new standard, and the compiler that we have in the live DVD can compile C programs written in this standard. So there are a few new things in the C11 standard that are not present in the earlier standards. We won't really be using C11 all that much. I'll try to highlight where we use C11. It is rather new, and actually the compiler that I will be using for these demos is an older one. It's the standard on Mac OS X, so it doesn't actually compile this standard. It does compile everything written using what's called the ANSI standard from 1999, so C99. Okay, so C is a small language, about 32 keywords. There's more than that now in C11, but that's pretty small. It's very portable. Almost every CPU that you have these days will have a C compiler. So take, for example, the CPU that's used in iPhones, those are the ARM processors. There's a C compiler for that, and as you probably know, the language that's native for iOS is Objective-C. Objective-C is built on top of C, and so you can be pretty sure that there's a good C compiler for iPhones. And if you take any Android machine, they're implemented on many different CPUs, but they all run Linux, and they all have a fairly recent version of the C compiler. So C provides basic features like variables, expressions, statements, control flow, and functions, but not classes. So variables like ints, floats, doubles. So we have types. C is a strongly typed language. But actually, I should back off that. It's somewhat typed. There are some holes in typing in the C programming language that makes it a little, we could say, dangerous to use. So you have to know what you're doing in many cases as far as type information goes. There are arithmetic expressions, statements just like in Java. So you can have compound statements starting with an open curly brace, ending with a close curly brace. Control flow, if statements, while loops, things like that, but no exceptions in the old C99 standard. So some of the more advanced features are in library functions. So for example, you've probably used printf, system.out.printf in Java, or printf in the shell scripting language for Bash, and printf in C++ if you've used that. That is implemented in a library function. So printf is not something that's built into C. It's not part of the C language. It's just provided in a library. Why use C? It's efficient. It's almost as efficient as assembly language. And so most operating systems today are written in C. So for example, Windows, written in C, Mac OS X, written mostly in C, Linux, mostly in C too. So just about every operating system these days will be written in something like C, and most of them are. Also, it's portable. It's probably the language with the most number of compilers. So any hardware that you have, you can write C programs for it, because chances are there will be a compiler for that particular hardware. And so you can compile most C programs for that hardware, and you're up and running. So let's take a quick look at a simple C program, and let's figure out the different parts of it. There will be a main, and in this case it's a function. I know if you're using if you used to Java, we call them main methods, but here in C it's called a function. So I'll try to stick to that. I sometimes tend to switch to either Java, the Java word, which is methods, or if I remember, I'll use functions. Speaking of Java, this pound include, and that's this hash mark is called pound. So this is a directive not to the C compiler, so this is not part of the C language, but it's part of the C preprocessor. And what it says is, take this file, standardio.h, and it will be in quote-unquote a standard place in the operating system, and take the contents of that and create a new temporary file with the contents of this include file plus this program, and then compile that. So in some ways it's like a Java import statement. So you can think of it as something very similar. It's quite different though. Okay. So if you were to set up a C program with a pound include, let's call it first.c, here are the steps that you can use to create an executable that you can run. First thing you'd want to do is use the CC program, or in our case we will use GCC. It's actually not any different. Usually CC is just a link to GCC, or somehow related to GCC. So we would say, all right, cc minus c for just compile, don't link, and compile this file first.c. This will create an object code file, first.o. So we'll get two files. You have start with the first.c, you say cc minus c, and we get an object file, which we have to now link with external C libraries. And there's a standard set of libraries that almost all C programmers use, not necessarily all. If you're on Windows, use a slightly different set of C libraries. But we will use the GNU or GNU C libraries, which is called GNU libc or glibc. So glibc files or information from glibc is extracted and joined with the object code to create an executable file called first. One thing to note is that on Windows systems we often use first.exe as a file extension. We do not have to do that in Linux. You can if you want to, but it doesn't make a difference. So you don't need the .exe file. Okay, so let's take a quick look at this. So we have this file already, first.c. It has a pound include, a main function, a printf, and then we return. Alright, so we say gcc minus c first.c, and it runs. It looks like it didn't do anything, but let's check. Sure enough, it did create a file. Here's our first.c. It is 78 bytes, and then when we compile it, we get an object file which is about 10 times as big, 736 bytes. Now, in this object code file, there's only a sort of a pointer or a link to the printf function, for example. So all of those library functions are not present in this .o, and so you cannot run this. You can try to run it, but you can't. Also, you can't really look at it. You can try to cat it, but oftentimes that messes up your terminal, so I'm not going to do it. It might be safe, but you can try to cat it, but you'll see just some things that are unreadable. So finally what we have to do is say gcc and say minus o first. That's saying create an output file called first from first.c. I'm sorry, first.o. So what this will do is it'll take first.o and take all of the information that you need from library files and create a first executable file. So now if you do an ls-l, you will notice that there is a first file. Notice the permissions. This file is executable. It has the X option set. And it is quite a bit bigger. It's more than 10 times bigger than first.o. So from a 78 byte C program, we created an 8K executable file in this case. This is on a Mac OS X. And so now we can run this. Can we run it using first? Well, we could, but in most systems this is not advisable. It's much better to say in the current directory execute, or execute the file called first in the current directory. So run this, and it prints out exactly what we expected, which is the contents of the string that's sent to the printf function. So there's our first program.